Okay. Okay, so for these intercepts, okay, well, again, let's get the x-intercept first. So as I said before, you set the other variable, in this case, y, we set that to be 0, okay? We're going to set y to be 0, okay? And that's what I'm doing here. So what we get after setting y to be 0, we get the point 9x equals 5. Excuse me, we don't get the point, we get that equation. So we have 9x equals 5, okay? And, you know, we just solve for x, right? You want x all alone. We have 9x, so we divide. Divide by 9, we get x is 5 over 9. I mean, I did write this as saying this point is on the graph, but really the answer is 5 over 9. An x and a y-intercept, they're just numbers, okay? They're just numbers. All right, that's cool. So that's what these are. So these are just numbers, okay? So again, we set y to be 0. That's the x-intercept. For the y-intercept, the idea is similar. You know, for the y-intercept, we set x to be 0. And that should be, this should be y. I don't know why I have that as x. Let me fix that. Okay. So now we set x to be 0, right? We calculate what y is. So we get 9 times 0 plus 2y is 5. Okay? So we get 9 times 0 plus 2 times y is 5. So that's what we get here. Okay, so now we solve for y. Not sure why I wrote the equation 2y equals 5 more than once like that, but I guess that's okay. But anyway, we have 2y equals 5. Once we set x to be 0, divide both sides by 2, because again, we want to know what y is. So we get y is 5 over 2. Okay? 5 over 2. So x is 0, 5 over 2. Again, this is on the graph. That's what this tells us. But really, the answer is this number, 5 over 2. You know, I'm emphasizing this a lot because in the past I've seen students, you know, make mistakes on this kind of question, which has been a test question before. So, you know, just letting you know. I mean, I did graph it using Desmos, and we actually do get a line. We'll go more into that in the next section. But you can see how these 2 points are on the graph. And since actually it turns out this is a line, I mean, we'll actually see that without graphing it in the next section. But, you know, just letting you know. It's mostly because you have x and y here, and they both have exponent 1. Remember, if the exponent is 1, you don't write it. So, all right. Okay, so we have that. That's good. I hope everyone understood that. All right. Another graph we saw was the circle. Okay? Right? Remember, as I said before, the circle, right? In the plane, if you have a point, HK, right? The circle is all points that are equidistant from the center. All points that have the same distance from the center. Center is HK. That distance is what the radius is. It's the length of the line segment here, connecting the center to any point on the circle. And here's the equation. That is, the circle here is the graph of this equation. HK is the center. R here is the radius. There are other ways to write an equation of a circle. There are other formats. But to really understand those, you need the method of completing the square. They do cover that in the book. I think I tried covering that once a while ago. Not in this class, but I mean like some semesters ago. But really for time consideration, I'm not going to cover it though. I mean, the book does go into it. It's not terrible, but it just, does get a little involved. Okay? All right. Let's do some examples with this. In fact, here's our first one. So let's say we have this equation. Let's say we want to graph that circle. Okay? Well, first, yes, we could use Desmos to graph it by typing in the equation, but let's see what the center and radius are. Again, this is here the standard form of an equation of a circle. The center is HK. And you can see just by comparing it, right? We have H is 3, K is 5. You could just see by comparing that. H is 3, K we could take to be 5. R squared is 5. So R, the radius, is radical 5, the square root of 5, in other words. Okay? So that's what we get here, the square root of 5 as the radius. So the center is 3, 5, x minus 3 squared, y minus 5 squared, and R squared is 5. That is, the radius is the square root of 5. Okay, now, if I remember correctly, I think this graph was not right. I don't know what, I think when I was writing up the notes, I think I had the equation here as I think I had the y value here as 2. And I changed this to 5, but I forgot to change the graph. So let me just get to the graph now, actually. I'll just share it on Desmos again. Okay. Let me just get to okay, so let me stop sharing this for a bit. Get to the Chrome. Here we go. Okay. I mean, this is actually how you graph it. When you get the Desmos and you get to the graphing calculator, you could type stuff in on the left here. This is actually where I had y equals x squared, as you can see. I didn't want them both there, so that's not there. Okay. If you ever need help graphing something, don't be afraid in Desmos or whatever, don't be afraid to ask me. But you can see this is the center. Let me zoom out a bit, actually. There we go. I did label those points. Oh, wait, that's not the right. Oh, my goodness, this is a different circle. Sorry, my mistake. My gosh. Wrong circle. Okay. Sorry, but that is this is right though, but the graph here is not right. The center should be instead 3, 5. Here it's 3, 2. Oh my goodness. Sorry, Desmos, that was for a different problem. I'm really sorry about that. But hopefully you still get the idea. At least I hope you do. Although I could, well, let me keep going. Oh my goodness gracious. Here we go. Okay. All right. Anyway, this was another one. I was going to have you guys try it, but why don't we do it together? Because I did that with my other class. Okay. All right. Anyway, so here, let's find an equation of a circle whose center is 4, 5, and whose radius is 3. Okay, so the center is 4, 5, and the radius is 3. That's the first example here. So again, it's really kind of like what we saw before, right? We have the center. I rewrote this here. The circle with center HK and radius R, right? That's the graph of this equation. That circle is the graph of this equation. But here we want a circle whose center is 4, 5, and the radius is 3. So instead of HK, we want 4, 5. That is, we can take HK, in other words, to be the point 4, 5, right? The center is 4, 5. For this, the center is HK. So we want HK to be 4, 5. Now, how do we pull that off? Remember, if 2 points are equal, let me draw it in, then their x coordinates are the same if they're equal, and their y coordinates are the same. So in other words, basically what I'm saying is what's to the right of it, h is 4 and k is 5. And since the radius is 3, we just take r to be 3. And so this is our equation. I probably over-explained it, I guess, but I guess that's okay. So, but hopefully you understand what I'm trying to say. At least I hope so. All right, let me just pause the recording.